Okay, so lesson 5 is a lesson where we are proving parallel lines instead of given parallel lines. So before we start it, I'm going to take a look at the proof reason sheet that you got, your pink sheet. You should have gotten it in your mailbox today, or it is posted on Google Classroom. So on this proof sheet, we actually have a box that is dedicated to proving parallel lines. And these theorems are mostly the reverse of the ones that we had yesterday. So the verse says, if two lines are cut by a transversal so that corresponding angles are congruent, then the lines are parallel. Since it's then the lines are parallel, that means our conclusion is that they are parallel. And we have all the same relationships as we had for when like parallel lines were given. Corresponding angles are congruent would give us parallel lines. Alternate interior angles are congruent would give us parallel lines. Alternate exterior angles are congruent, then the lines are parallel, or same side interior angles are supplementary. Remember that one, supplementary, not congruent. There are two more, but these two we're not going to really use until we get a little bit further in the proof. We aren't really dealing with perpendicular lines yet. So before we do this proof, I will admit I do have a little typo here. When I was copying and pasting this, we don't actually need this given, and you will generally not be given something just to throw you off. So let's just get rid of that one. We don't actually need it. So all we're given is that the measure of angle 1 is equal to the measure of angle 2. Well, we're trying to get A and B parallel, which means we need one of those special angle relationships. And you might realize by looking at these that we are actually already looking at alternate exterior angles. So if we can get the alternate exterior angles congruent, we can conclude that these lines are parallel. So that's where I'm going to start. I'm given that the angles are equal, however. And to get parallel, I do need to switch this to congruent. So angle 1 is congruent to angle 2. And our reason here is congruent angles are angles with equal measure. Sorry about the messy handwriting. I'm working on my home computer, so it's not quite as easy to write. Now we have our alternate exterior angles congruent, and that is enough to convince me that A is parallel to B. Our reason here is if two lines are cut by a transversal such that alternate exterior angles are congruent, then they are parallel. And we're done. Now this is one way to do this proof. This is not the way to do this proof. I happen to see the alternate exterior angles, but it's possible that someone else didn't see that. Maybe they see that angle 2 matches angle 3 because they're vertical. And then they say, well, if 1 matches 2 and 2 matches 3, 1 has to match 3 because of the transitive property. And now they're looking at these two angles, which are corresponding. That would give us parallel lines. That's fine. Someone else might say, well, 2 matches 3, and 1 matches this angle right here. And they could use some fancy transitive property to show that these angles match. And now they're looking at alternate interior angles. So we have options, but I wanted to stick with the shortest way to do this proof. And that is to go with just using the given angles, angle 1 and angle 2. The second proof that we have, I'm going to do in another video only because the app that I'm using to film this one is a free app and it limits me on time.